going to quickly take a look at three different types of discontinuities. We're going to take a look at an example of a jump continuity, an asymptote or an essential discontinuity, and a point discontinuity, which usually shows up on a graph as a whole. So the first thing we're going to look at here is a jump continuity. And a jump continuity is exactly what it sounds like. You got a graph. As you travel along the graph, somewhere there's a jump from one piece to another piece. You can see here it's defined up here, not defined in this region here, then continues here. And jump continuities always have different limits from the left and from the right at the point where there's a jump. And there's a couple types of functions that we'll have. These will be piecewise function and the greatest integer function. An asymptote, which is also known as an essential discontinuity, is basically you got a vertical asymptote in the middle of the graph here. So the graph is divided into two pieces. It's very obvious that this is not a continuous function. We have a piece and then a separate piece. And these you'll generally find in rational functions where the denominator is equal to 0 and the numerator is not. That's where you're going to get an example of an asymptote, is a discontinuity. And the third type of discontinuity we're going to look at is a point discontinuity. So this is basically a graph, and the graph goes along as normal, and then one spot, could be multiple spaces, but there's one place right here, gap. There's just one gap, and then it continues as normal. So the difference between this and the jump continuity is the jump is two distinct pieces that do not connect or look like they should connect. This looks like it should connect, and that it's just kind of got this weird little hole in the middle here, and after that it would go on its merry little way. And in another video we're going to do, you're going to learn how to remove these. These are also known as removable discontinuities, the point discontinuities, because you can slightly redefine a function and actually remove this little hole here and make it a continuous function.